Hello everyone, I hope that you are doing well. In the previous videos, we learned how to make topologies. In the first code, we created a small network including two nodes, one client and one server. Then we learned how to trace them by ASCII tracers or pcap, and after that we expand our network to contain two parts, one part for point to point and the other part for LAN. Okay, in this video we are going to add Wi-Fi nodes to include wireless communication in our topology. For this we are going to analyze the third example of the NS, which is in, as you know, in examples tutorial. Okay, third. If you look at the code, the first parts are like the previous codes, okay, the comments and the headers. But you should notice that here we have some new includings. We have Jan's Wi-Fi, which is the Wi-Fi model that we are going to use. We have mobility, that we are going to use the mobility helper to make our wireless nodes move. And okay, we have SSID, that is for the MAC configuration that we will learn shortly. Okay, as the previous codes, the next part is for the schematic of the topology. The right part is like the previous topology. We have two point-to-point devices and four CSMA devices, and one is using both point-to-point and CSMA device, and this part is for the LAN network. The left part is new. Here we are going to add four wireless nodes, one of them as access point. So on N0 we are going to insert another device, so making it function as an access point. And we are going to have three station nodes that they can move and connect to the access point. We have three parts, so we have three base IP: 10.1.1.04 point-to-point, 10.1.2.04 LAN or the right part, and 10.1.3.0 for the Wi-Fi part. So like the previous code, we will need global IP routing to make the network transmit the packets. The next lines of codes are exactly like the previous ones, defining namespace and defining the log component for logging the console messages, and then we move on to the main body of the code. Okay, in the beginning we have some new variables. Variables, like the past code, is for controlling the log component. If it is here, okay, if it is false, the logging is going to be disabled. We tested in the previous video. And if it is true, okay, the log component is going to log messages like the previous video. Okay, so we can change it to true or false because it's a boolean variable. Then we have n CSMA, exactly like the previous video. It is number of the CSMA nodes, so 3. It means here we are going to add 3 nodes, and we have number of Wi-Fi nodes. It is new, and here we put it 3. So 1, 2, 3. Tracing is another boolean variable that we have added. When it is false, it means the tracing is going to be disabled, but when it is true, the tracing is going to be enabled. It is for here. Okay, so we are going to put it as enable, so true, so the tracing is going to be enabled. If you have watched the previous video, you can see that these codes are for entering the values from the terminal or from the command line. You can change the variables from the command line. So let's move on to the next lines. This part is for restricting the number of the Wi-Fi nodes. You can set it, for example, to 10, 12. If we are going to set numbers to more than 17, so it is going to write that you should choose a number less than 18, and it is going to finish the program. Okay, and this part I've told you that it is for enabling and disabling the log component. Okay, again, similar to the previous code, here we defined two point-to-point nodes by using node container class and defining a point-to-point nodes named object. Okay, then by using point-to-point helper, we define an object point-to-point and set the attributes by using these two lines: data rate to 5 megabits per second and delay to 2 milliseconds. In this part, if you have any confusions, please watch the previous videos and look at the detailed explanations. Okay, after that we are going to install point-to-point on our point-to-point nodes. So we have new devices containing point-to-point protocol, so we need a net device container to keep the devices. We repeat the same procedure for the CSMA nodes. We define an object by using node container. If you remember, we took the second node of point-to-point. The index is 1, so the node is the second one. This is the first point-to-point node, this is the second, index 0, index 1. So we took this out of took this node and added to the CSMA part. Then we create 3 more CSMA nodes. So the first node from point to point, the next 3 from the next 3 are the new ones. After that, by using the channel attribute, we define the data rate to be 100 megabit per second and the delay to 65-60 nanoseconds. So we installed CSMA on CSMA nodes, so we have CSMA devices. As a result, we define a net device container and put the devices in that container. Okay, until here everything was exactly like the previous code. Again, if you have any questions in these codes, you can refer to the previous videos and watch the detailed explanations. From this point forward, we are going to define the wireless part. Okay, so you should have a basic knowledge about wireless communication, so the codes are going to be familiar to you. Okay, the first part is for defining the station nodes, the 3 nodes that we have, and they are moving. So again, we use node container to define an object, Wi-Fi STA, which is station nodes. Then we create 3 nodes, because in Wi-Fi is 3. Okay, so we have N0, N1, N2. What is the last node? This is the last node. We created these new nodes, but we want to have this one in the Wi-Fi part and acts as an access point. So what should we do? We should get the first node. Okay, the index is 0, so it is the first node. First node from the point to point and add it to the Wi-Fi part. This is the container. Okay, we add this one to the container. Until here we have our nodes. When we want to create Wi-Fi network, the physical and the MAC layer is going to be different from the wired ones. Okay, in the wired networks, physical and MAC layers are designed in a way that can communicate using wired medium, but here the physical and MAC layers should be changed to be compatible to Wi-Fi networks. Okay, what is the first step? The first step is defining the physical layer and associating the channel, wireless channel, to that physical layer. So, by using Jan's Wi-Fi channel helper, which is a model for creating Wi-Fi channels, we define a new Wi-Fi channel or wireless channel. Okay, and we use the default parameters. You can change them by using the attributes that I have taught you in the beginning videos how to find them. Okay. After that, by using Jan's Wi-Fi helper, we define the physical layer. What is the next step? Okay, if you look, I have added some comments to clarify the codes. When you are watching the video, you can pause the video and read the comments. Okay, so once these objects are created, channel and physical, we create a channel object, and it means here we create a channel object and associate it to our physical layer. Okay, we associate it to the physical layer that we have. This is because we want to be sure that all of the nodes that are using the physical layer are using the same underlying channel. Okay, so we create channel, we create the physical layer, and then we associate the channel to the physical layer. Now we have our channel, we have our physical layer that can function through the wireless or Wi-Fi communications. Okay, once the physical layer is configured, okay, everything is configured. What is the next step after the physical layer? It is time to create the MAC layer. The first step is to create a Wi-Fi object by using Wi-Fi helper. Then set the remote station manager to AARF. Okay, what is this? It is AARF is one of the IEEE rate adaptation mechanism. Okay, we choose it because we are going to have a rate adaptation in our simulations. Okay, if you read the comment, once the physical helper is configured, we can focus on the MAC layer. Here we choose to work with non-quality of service MACs. Okay, after that we should configure the different parameters that we have. Okay, let's move on to defining the MAC object by Wi-Fi MAC helper. When we define the MAC object, we can change the attributes. Okay, we can define the SSID. Okay, we can change the active probing. But if you want to see these attributes but you don't know where they are, I'm going to teach you here a method that you can use it to find the class that contains these attributes. If you remember, I've told you the modules are in the source folder of NS. Okay, we go to the source folder and we are working on Wi-Fi. What are the classes? They are in the model folder. Okay, but there are a lot of classes here. And okay, for example, as an example, we want to see which file contains active probing feature. Feature or attribute. Okay, they can use interchangeably. What should we do? Okay, we should open terminals. We go to the folder that we want to search the file. Okay, source, Wi-Fi, and model. if you look at this address, okay, NS source Wi-Fi mother. Okay, we have a well-known command in the terminal that it can help us to find the things that we want. What is that? Okay, we write find point dash name, then double quotation. What kind of files we want to look into them? We want to have a look on .cc files. Okay, then we put these commands and we grab the things that we want to find. For example, we want to find the active probing attribute. Okay, we paste here. Okay, have a look on the command find point dash name ccx args grep active probing. Then run. If you look, it is showing that it is in the sta dash Wi-Fi dash mac dash cc, and even it is writing the code that it includes. So we go to this file, sta Wi-Fi. Let's find it. Okay, it is here, sta Wi-Fi. This is a class that is including these features. Okay, let's find active probing. If you look here, you can see the attributes. Okay, which one we want? Active probing. If you look here, there is an explanation that you can read it and learn some useful information. And the type of the attribute is boolean. Okay, and it is false by default. But okay, in the program we defined it as a false value. Okay, so this mechanism can help you to find the things that you want to see and to find the place of that in NS. You can grab it and you can find it easily. Okay, until here, what have we done? We created the channel, we created the physical layer, we associated the channel to the physical layer. We have our nodes, okay, Wi-Fi station nodes, and when we have all of them, what is the next step? Like the previous programs, we should install Wi-Fi on the physical Mac and Wi-Fi station nodes. What is Wi-Fi? It is an object of Wi-Fi helper. So in this case, we have a new device that contains Wi-Fi protocol. So we put this device on net device container. So net device container includes our Wi-Fi station nodes, the three most left nodes. So after defining the station nodes, this is the term to define the access point node. If you look here, over here the MAC type is station Wi-Fi mode. So we need to change it to MAC type to access point mode. Okay, so that the node can act as an access point. Then again, we after changing the MAC to access point mode, we install physical MAC Wi-Fi. Physical MAC, we install it on physical MAC and Wi-Fi access point node. Here it was Wi-Fi station nodes. So here we have a device that can act as an access point of Wi-Fi. But here we had three devices that could be able to act as Wi-Fi station nodes. So we have a new device. We put it in access point device. So station devices contains our station nodes. Access point device contains our access point. By this we could complete this part. 3 station nodes one access point node. Now let's continue. What's the next step? Okay, we have 3 Wi-Fi nodes, but if they are not moving, okay, what is the purpose of defining these nodes? So we need to have a mobility to install on the station nodes to make them move. If you look from mobility, we choose set position allocator and some attributes. Okay, I can explain them, but if you remember in the previous videos, I taught you how to find them and how to know what they are. So let's repeat that procedure for position allocator and especially for grid position allocator to see what min x and the others are. Okay. If you remember, for this I've told you go to NS website. Then we should go to the documentation part. Go to the latest release. Go to the API documentation. After that, classes, class list, and NS. Okay, what are we looking for? Grid position allocator. Okay, let's find it. It should be over here. Okay, grid position allocator. Okay, if you remember, I've told you go to more. This is an explanation, and you can see the attributes here. Grid width, min x, for example, the x coordinate where the grid starts. This is, and the others you can see, for example, delta x, the x space between objects. So you can find the attributes over there and change them as you want. Okay, min x and min y, they are starting from 0, and the delta for the first one 5 and for the second one 10. Okay, we have our grid. After that, it is the time to set the type of the mobility that we want to set on the nodes. Again, from the mobility, we choose set mobility model, and we choose a random walk to the mobility model. Okay, again you can go to NS website and find the attributes and the definition for that. Okay, we can do that. Random walk to mobility model. Again, more, and look at the attributes. For example, here we have defined bounds, and I have written here bounds of the area to cruise. Look, it is from here, bounds of the area to cruise. So right now we have our mobility model, and we want to install them on the Wi-Fi station nodes because they are going to move. So by using install method, we install the model that we defined on Wi-Fi station nodes. After that, we want to choose a model for our Wi-Fi access point. What kind of model? Because we don't want our access point to move, we choose constant position mobility model. Again, you can look at the documentation and see the definition, and we install this model on Wi-Fi access point node. So our 3 station nodes are moving randomly, that we are going to trace the position at the end of the coding, and our access point is fixed. It is not moving, it is still. After that, okay, we have everything that we want: nodes, mobility model, okay, devices. The next stage, the next step is for defining the protocol. So we define a stack from the stack protocol, internet stack helper, the protocol stack, and we install the protocol stack on all of the nodes. Again, like the previous videos. Then we need to assign IPs to our nodes. We have 3 base IP here, so we set them and install them on the nodes. The first base IP on point-to-points, the second on CSMA, and the third on station and access point, exactly like the previous videos. And after that, we should define our application. We define a UDP echo server like the previous codes, which is listening on port 9. Okay. Then we install the echo server on the CSMA node, the last node, because NCSMA is 3, so the 4th node, and we put it in the application container. We are going to start our application at 1 and finish it at 10. Now it is time for UDP echo client. So in this line of code, we are going to define the UDP echo client. It is going to send the packet to the rightmost node of CSMA, so we get it from the CSMA interface, and it is going to send the device to port number 9. The number of the maximum packets 1, the time between the packets 1, and the size 124. Which node we choose to install the client? If you look, it is Wi-Fi station node 3 minus 1, so it is 2. It means the last node that we have defined for Wi-Fi. Okay, if you look, the IP base IP for the Wi-Fi is 10.1.3.0, so it's going to be 1.10.1.3.3, the last node. We install it, okay, and we keep it in an application container. And because we have different parts here, we should have a routing, so we use IP for global routing helper. It is going to help the network, the packet, to be routed all over the network. If you remember, I've told you that this line makes life easier for us, and just by putting this, the packets can be routed in the network. So after that, we stop the simulation on time 10. For tracing, again we are going to use pcap. We are going to enable pcap on all of the point-to-point nodes. We are going to enable pcap on the access point, okay, and we are going to enable pcap on CSMA, the first node. It means the right node of the point-to-point. If you remember, this line is for making this node to sniff the network. It can provide a lot of information for us. Then we run the simulation and destroy it for clearing. The next step is to run the code. Okay, let's close this. Let's close the terminal. Okay, if you remember, I've told you for running the code, you can move the code to the scratch folder, so you can run it on the fly. Okay, let's open terminal, go to the NS folder and the main folder. Okay, //waf, it was for the running. Which folder? Scratch, which file? Third. can see we have log messages. At 2, client sent 1024 bytes to 10.1.2.4. Okay, the rightmost node. And at 2 the server received the bytes from 10.1.3.3 the client, and after that echoes it, and the client is going to receive the echo. If you go to the main folder of the NS, you can see there are some pcap files here. Because we have the files from our previous simulations, we can delete all the pcap files, then run the simulation to have only the pcap files for this simulation. Okay, for this we write rm remove star point pcap. Okay, if you look, the folder is more clean. So let's run the simulation again. Here we have only 4 files that we have created for our new code. Third.cc. Okay, if you remember, node 0, device 0, node 0, device 1, node 1, device 0, node 1, device 1. Let's have a look on them. I'm sure that by now you know how to analyze and how to get information from the pcap file, but just to be sure, let's have a quick look on them. If you remember, for having a look on the pcap files, we write tcp dump -tt -na-r, then name of the pcap. For example, let's have a look on the first one, the first node. Okay, it is just talking about the sending packet from 10.1.0.0 to the server. Okay, then echoing the packet to the client. Let's change it to the next one. Here it is like that. Okay, now let's have a look on 0, 1. It is going to be interesting here. This is the node that is the first node. I mean this one. But the second device is for the access point, so it provides more information for us. For example, the first main difference is this one. In the above, the link type was point-to-point, but here it is 802.11. Okay, it is the standard for Wi-Fi. So you can see other information that is related to the Wi-Fi communication. It can trace different events for the Wi-Fi communication at different points. If you are interested, you can search them on the internet, and you can see that each information is for what. And let's have a look on the last pcap file. If you remember, this node and this device was for packet sniffing. It is like the previous video. It shows the link type. It is Ethernet. It is creating ARP to get the MAC, and so on and so forth. Okay. Before going on to the mobility tracing and having a look on how we can trace the position of a node, let's have a quick review on this code. I know it was a little complicated. You can watch the video a couple more times and you can practice to get the intuition of the code. Okay, we have three parts in our topology. The left part is for the Wi-Fi, three station nodes, one access point, this is the base IP, and point-to-point part and LAN part. This node has two devices, one for point-to-point, one for Wi-Fi. When we look at the different pcap, we can see different information, and the information for the Wi-Fi part was a lot. This node has two devices, one for the point-to-point, the other for the LAN, and the second device was defined as the sniffer, so it could sniff the packet. Until here, everything was like the previous code. We defined the point-to-point nodes, we defined point-to-point protocol and install on the point-to-point nodes and make new devices and put them in a net device container, and such a functionality for the CSMA. But when it is time to define Wi-Fi nodes, we should define physical MAC layers and we should define the channel. Okay, by using Jan's Wi-Fi model, we create channel, we create physical layer, then associate the channel to the physical layer. So all the physical layer objects created by the Jans share the same underlying channel. After the physical layer, it is time for creating MAC. So we define object from Wi-Fi helper. Here the type of the MAC is station, and but for AP it is access point. So we install them and we have station and access point nodes. Then we define mobility to install them on the station nodes so we can force them to move, and defining protocol stack, IP and UDP, client and server for client and server nodes. Now it is time to trace a node that is moving. We install the mobility on the station nodes. They are moving randomly, but we want to know the positions that they have. So for this I have written a code for you like this. In the beginning we define a function called course change. The most important functionality of this function is to trace the position of the node. It gets the model, and by the help of the get position method, it gets the positions and store them in a vector variable called position. Then we are going to log it to the console, the X and Y position of the node. So let's copy this to our code and put it before the main body of the program where we define our functions. Next we want to trace one of the station nodes. We want to trace the last added node to the Wi-Fi part. Here the most important part in this code is these two lines. If you remember, I've told you we have a node list that contains all of the nodes that we have created. So from the node list we get the last added Wi-Fi node. 3 minus 1, 2. This is the last, and we get the idea of that node. The $sign implies that the mobility model is aggregated to the node 7s, and we are hooking to the course change. I have put a comment here for you to understand that this part is for getting, I mean the entire part is for getting the number of the code. So it is number 7 here. Let's copy the code to the program before the time that simulation is going to stop. Okay, let's run the third file and see the results. So if you can see, the x and y position have been written here, and the node is moving randomly. Let's change this one, for example, to true, and see the results. Okay, this time the trace is for node number 6. In the previous one it was for number 7. Okay, I know this video was a little complicated. Maybe you will need to watch it a couple more times. Okay, you can ask any questions you have in the comments and we can talk about the questions.